Hey guys, let's talk about solving one-step equations. So I'm going to kind of talk about just solving equations in general. It's something I'm probably going to talk about in all of my solving equations videos, just so you kind of get in the habit. So the whole idea about solving an equation is we want to get x alone. We want to get x alone. That is the plan. So you can kind of read the problem, figure out on the left side or the right side of the equal sign, where's x at? And we're going to have to use some mathematics to try and remove whatever operations are with the x and get x alone. Now, it's not going to fully apply here, but when we get into more complex equations, the whole goal of getting x alone is a lot of people understand, all right, I want to get x alone. I know how to remove and move numbers and all that, but I don't know what to do first. What you're going to do is, and why we do the order of operations PEMDAS, when you're solving equations, you're really doing PEMDAS backwards. So we're going to get rid of any addition, subtraction first, multiplication, division, then get rid of exponents, then get rid of parentheses. We want to work backwards, and we want to get x alone. And the way we're going to do that is by doing inverse operations, meaning the opposite of addition is subtraction. So if you want to get rid of addition, use subtraction. If you want to get rid of subtraction, use addition. And the other thing we're going to talk about today is multiplication and division. Those are also inverse operations. So if you want to get rid of multiplication, use division. You want to get rid of division, use multiplication, vice versa. Okay. So here we are, our first problem, 5 equals x minus 7. What I like to do is I always like to draw a line straight down from wherever the equal sign is, and we want to get x alone. Right now, x is on the right side of this equation, and we have x minus 7. So currently we are subtracting 7 from x. I need to get rid of this minus 7 piece, and I'd like to send it to the other side of the equal sign. That way we get x all alone. So the opposite of subtracting 7 would be adding 7. But here's the deal. Since I want to move it to the other side, I got to do it to the right side. I got to do it to the left side. So what happens here is on the left side, we're now going to simplify. So I have 5 plus 7, which is 12. On the right side, I have my x, but I also have a minus 7 and a plus 7. Negative 7 plus 7 is 0. What a lot of students like to say is those cancel out, but it goes to 0, and you don't need to write that. So we have our x by itself, and we have x equals 12. So I believe this is my answer, but I want to check your work. The way to check your work is you're going to take your answer, plug it back in, and see if both sides equal the same number. So checking it would have 5 equals, instead of x, let's put 12 minus 7. And we want to simplify both sides of the equal sign to see if they equal each other. So on the left side I have 5, so nothing to do with that, it stays 5. On the right side I have 12 minus 7, which is 5. So I get 5 equals 5, which is true. Therefore I know x equals 12 is my answer. So let's go to the next one. I have x plus 3 equals 3. Again, draw that line down the equal sign. That way I know if I do something to one side, I got to do it to the other. My x is currently on the left side, and I have x plus 3. So I need to get rid of an addition of 3 and send that to the other side. The opposite of adding is subtracting. So if I have a plus 3, I want to do minus 3. If I do it to one side, I have to do it to the other. Subtract 3 from both sides. And then let's simplify here. On the left side, I have an x, still there. I have a plus 3, minus 3. A 3 minus 3 is 0, so those are gone. On the right side, I have 3 minus 3, which is 0. So I have x equals 0. That is totally okay for an answer. A lot of people freak out and say, well, no solution. No, that's totally fine. So let's check it, make sure it works. We're going to plug 0 in for x up above, so that's 0 plus 3 equals 3. Clean up the left side, 0 plus 3 is 3. The right side, have a 3. 3 equals 3, we're good to go. One more addition subtraction problem here. So I have 17 equals x minus negative 3. Now, a lot of different ways you can approach this. I look at this and think, you know what, I can clean this up a little bit. We have two negatives right next to each other, or two subtractions right next to each other. Remember, when you have a negative or a negative and a negative, we actually have a positive. So I'm going to change it to x plus 3. Draw my line down. We just have to solve this now. So I have an x. I have a 3 added to it. To get the x by itself, the opposite of adding 3 is subtract 3 from both sides. 17 minus 3 on the left side is 14. Still have an equal sign. On the right side, I have an x, and a 3 minus 3, that's 0. So we have x equals 14. Just need to check it now. 17 equals 14 minus, parentheses, negative 3. Left side is 17. Right side, a 14 minus negative 3. You could use a calculator if you need to, but that is also 17. So this answer works out. A few more examples. We're going to switch to addition, instead of addition subtraction, we're going to switch to multiplication division. So I have 5x equals 25. Draw that line down the middle. So right now, x is on the left side. It has multiplication by a 5 with it. When you see a 5x, that means 5 times x. So I want to get rid of this multiplication and send it to the other side. So the opposite of multiplying by 5 is we're going to divide by 5. But if you divide the left side, we're wanting to move this to the right side, so divide the right side by 5. So now I just have to clean this up. On the left side, when you're multiplying and dividing by 5, 5 divided by 5 is 1. So really you would have 1x, which is just the same thing as x. Because 5 divided by 5 is 1. Still have the x there. 1 times x is still x. So what a lot of people say is, students will say that cancels, but really just divides the 1, and you just have the x. On the right side, we have 25 divided by 5, which is 5. As always, we want to check our work, so we're going to take this 5, plug it back in for x up top, and see if it works. So we're going to have 5 times 5, because I replaced the x, equals 25. Simplify the left, 5 times 5 is 25. Simplify the right, 25 is just still 25, so it works. Another example, 18 equals negative 3x. We gotta get that x by itself. This is negative 3 times the x. Negative 3 times the x. The opposite of multiplying by negative 3 is dividing by negative 3. Yes, we can divide negative numbers, positive numbers, it doesn't matter. Negative 3, divide the other side by negative 3. Clean this up now. 18 divided by negative 3 on the left side is going to be negative 6. On the right side, that negative 3 divided by negative 3, that really just becomes a 1x, which is just x. So the negative 3's are gone, and you just get x. So we have x equals negative 6. Gotta check it. So we have 18 equals negative 3 times negative 6. Negative 3 times negative 6 is 18. So we get 18 equals 18. Final example. X divided by 4 equals 7. Our x is on the left side. It's currently being divided by 4. I want to get rid of this division by 4 and move it to the other side of my line here, the other side of the equation. So the opposite of dividing by 4 is we're going to multiply by 4. Multiply the left side by 4, multiply with the right side by 4. Now on the right side, 7 times 4 is 28. I'm going to show you kind of what happens here on the left side. If you multiply 4 times x, you have a 4x divided by 4. And then 4 divided by 4 is 1x, which you really get x. So what a lot of people are going to say is when you're multiplying and dividing by 4 here, a lot of students will use the word cancel, but really what's happening is these are going to divide to 1, so you just get a plain old x. So we get x equals 28. As always, we want to check, so 28 divided by 4 equals 7. Check the left side, 28 divided by 4 is 7. The right side is 7. 7 equals 7. And that was solving one-step equations using addition, subtraction, multiplication, and division.